Hey guys, it is Dr. Graham Walker, emergency physician, co-founder of Off Call. And I get questions all the time from physicians like, how do I get involved in AI? How do I even start to learn about it? So I'm going to do a little screencast just showing you how you can try out a new model from Google. We are doing a free webinar event, myself and my colleague and friend and med school classmate, Sarah Gabauer, talking about just kind of like going over an overview of AI. We'll keep it really simple for clinicians. So feel free to sign up here. We would love to see you. But let's dive in. We're going to talk about this model called MedGemma. So Google just had their big conference and they released a new model called MedGemma. Gemma is Google's list of models, I think, like kind of similar to Gemini. These are open models, meaning you can use them for more purposes. You can see a little bit more behind the scenes. Google has one specifically called MedGemma that we are going to look at. And MedGemma has a couple different versions. The two main ones are a smaller model, and that's what we'll look at today. And it's a multimodal model. That just means it can like do imaging, not just text. And I'll talk about that briefly. And that's a 4 billion parameter model. So as models get bigger, as you see bigger numbers like 4 billion versus 27 billion, think of that as like you need a faster computer or a, like more RAM, more memory to look through that model. And then they have this other 27 billion parameter model that's like really good at text, but it doesn't do images. So that's kind of one of the main differences to think about between these two models. The 27 billion parameter model, like really good at text, but in the 4 billion model, pretty good at text, or really still good at text, but can also do imaging like chest X-rays, and that's what we're going to look at today. Okay, so I know AI can seem kind of overwhelming. I just wanted to let you know, look, if you are in medicine and you have any concept of what is actually on the screen right now, and you have a general sense of what a renal tubule is and what the distal part of the tubule and the collecting system is, you can figure this out. Even for my orthopods, if you know what this drug is, you can figure this out. Please do not be intimidated. I'm going to walk you through this. And Google really has made it really easy and free for you to try this out. And I think there's no better way to try this out, to learn about AI, than to just give it a try. So I'll link to this web page. This web page is for a website called Google Colab, and essentially it allows you to get free access to like a server, a computer in the cloud that has a bunch of RAM and has the necessary hardware to run some of these large language models. And again, this is totally for free. Because it's on the free version, we are going to run the 4 billion parameter model. That's a smaller model. It needs less RAM, but it can also do images, which is pretty cool too. Again, I'll link to this. You'll just click this link, and a page just like this will show up with your with your Google account, and it literally tells you every step to get this thing started. I've done some of the steps ahead of time since I'm doing this as a screencast. It does take several minutes to get it up and running because it's downloading like gigabytes of information into this computer in the cloud, and then you'll have to like just make a little account on a website called Hugging Face. It's super easy. You've made accounts for millions of other websites. And then all you do is you're just going to go through and start clicking this play button under each step here. And that's going to kind of slowly download and load, and think of it like installing software as you go. So you can see it's already installed a bunch of these programs here that are hundreds of megabytes in size. And now we're getting into a little bit more of the configuration of the MedGemma model. So it's that 4 billion parameter model here you can see on the screen. And now here's where you can edit your prompt and tell it what image you want it to test. So here the prompt I've said is interpret the chest X-ray. Tell me specifically if you think the patient has had any procedures in their thorax done. You could imagine you could come up with any prompt you want here. You could say, interpret this chest X-ray in rhyme. You could say, interpret it in the stylings of Stephen Colbert. You could have it focus. Don't tell me anything about the bones. You can prompt this to have it decide how you want it to respond. And I've gone ahead and found an image that's an open source image from Wikipedia, but I specifically like stripped out all the information about it and I put it on a different web page and I changed the name of the image file itself because these models are trained on available images and data. And so I wanted to not like let it cheat. These models will do their best to give you an answer, but if it's already seen this image before, it's kind of got the answer key ahead of time. So I've done my best to hide this information, and I've done this on this image several times. It's done a really good job. Now, the system instruction is something you can change here as well. Essentially, the default is like you're an expert radiologist. You could also change this to say like you're a pre-med or you're a medical student. What are the expectations you would think a med student should know about this image as well? The system instruction is kind of like how you want the model to behave overall, and then the prompt is maybe a little bit more specific what you want to get back as your response. And then again, you're going to click this button. This took about 2 minutes to load all this information. And then I'm going to go ahead and click this to start getting the output or the response from the model. It is going to take a minute or two. So I'll just kind of keep talking about the model a bit, and then we'll hop back to the response. Okay, so MedGemma and large language models often have things called model cards, and this is an idea of trying to have a one-stop shop for all the information you need about an AI model. So you can understand links and how to use the code. You can understand how it was trained, how it works, or how it doesn't work. So if you hear the word model card, think of it like a nutrition facts label, or think of it like a place that you can find all the information you need, hopefully about the model. And I'll just scroll through this here. This is the MedGemma model card. It's describing what is MedGemma. It's describing how it works. Here's some sample code that's very similar to the code that you saw on my other screen here. Some examples on like what technical specifications you might need to run the model, how to cite the model if you're talking about it in academic literature. And then it's going to give you some metrics and benchmarks, how it did on a bunch of different tests. This is like a chest X-ray interpretation test. You can see the text evaluations, looking at kind of multiple choice question answer sets from like USMLE and stuff. I've talked about benchmarks with multiple choice questions. I don't think they're the best, but it is one way to look at a model. There's some stuff about ethics and safety, which is obviously important, and then what the data was trained on. How does it know how to read a chest X-ray or a CT scan? You can see that it's also been trained on histopathology images, ophthalmology, dermatology. So it is able to do not just chest X-ray, and you can see all the different data sets that have been used to train this model and their citations as well. I'll just briefly talk about the restrictions on this model, the terms of use. Just like you click terms of use on every software these days, there are terms of use for this model as well. The cool thing about this is you can technically use this in commercial usage. So a company could use MedGemma in a commercial product. Please don't stop the video there. There are lots of caveats, lots of legal concerns here. Essentially, it's what Google is saying is you could use this, but you have to get regulatory approval in whatever country you're in. You can't make it do something that would get Google in trouble, essentially. And importantly, you can't use it on clinically, especially right now. It's certainly not at a level that I think anybody would think this is acceptable to use in front of a patient or in place of your clinical judgment. So obviously, you need to read these terms, but they're actually way more open than obviously other language models like Google's Gemini models or OpenAI, where you really can't see anything behind the scenes and you have way different terms of what you're allowed to do. Let's look back. I bet this model is done interpreting. So here's our chest X-ray image. So here's the prompt from me, the user. Interpret the chest X-ray. Tell me if you think the patient's had any procedures. And now it's showing me the image that it got from that URL, and it's going to interpret it here. And it's going to say, okay, yeah, it's a frontal chest X-ray with a pacemaker. and there's some cardiomegaly, and I would agree with those interpretations. This is a pacemaker here with wires in the right atrium and right ventricle, and there's some cardiomegaly, meaning that the heart looks a little bit enlarged. Generally, if it's like more than half the size of the thorax, we call that cardiomegaly. And it's going to give some specifics about the heart size and the lung fields, and that the mediastinum, the middle of the thorax, is unremarkable and looks normal. And now it's going to go specifically into what I asked it. Hey, has this patient had any procedures? And based on the image, it's difficult to tell, but the presence of a pacemaker suggests they have a pacemaker. So again, you can see how that's maybe not a perfect answer to my question, but the fact that it's able to see a pacemaker and interpret that, yeah, pacemaker probably means that they've had a cardiac procedure, is pretty interesting. I've tested this X-ray with lots of other things. I've asked it to come up with a differential, come up with a bunch of stories about, you know, what might have happened to the patient to get what you see in the chest X-ray, cardiomegaly, and a pacemaker, things like that as well. So pretty impressive. I will say I've had it try with a couple different like cuts of CT scans of like CT of the chest or CT of the abdomen with like a pretty, to me, classic looking aortic dissection, and it missed that. It said it did not pick up on the aortic dissection. So again, these models are for testing, for you to get a little bit more comfortable and familiar with how these models work, how they fail, so that you can start to understand how these might be helpful or not helpful in your clinical practice. But there's no better way than just like diving in and trying this out. So we talked a little bit about the model card and the terms here. I always like to tie this back a little bit to clinical medicine and to research as well. So you might look at this image here and think, well, how does it know that there's a pacemaker? What is it seeing? Is it really seeing the pacemaker? What's it doing? And wow, wouldn't it be cool if it could like highlight why it's saying what it's saying? And personally, I love that idea. I love that the machine could give me an inkling to why it's saying what it's saying. But even that concept is not without challenge. This is a paper from JAMA from about a year and a half ago now, and it essentially gave clinicians a chest X-ray um, showing heart failure, and then it had an AI model do a couple different things. One, it tried to explain why it was heart failure, and then it had another AI model that was biased, that actually intentionally misled the doctors about saying that, oh, it's not heart failure, it's pneumonia. So this is that image blown up from the paper. It's a great paper. You should definitely check it out. So essentially, in the top left here, it's saying, yep, this is heart failure, and the clinicians agree, yep, it's heart failure. Now, in the top right here, you can see there's some weird green markings here in the kind of right upper periphery of the patient, the left upper part of the image here, and it's saying, oh yeah, that's significant. Look, that's pneumonia. That's not pneumonia. That's like where the ribs and the scapula are. It's not a particularly common place for pneumonia to show up. But unfortunately, the clinicians believed it. The clinicians looked at this thing and said, I guess the machine's right. It's seeing something that I'm missing, but it wouldn't lie to me. And so, yeah, I guess maybe it is pneumonia, not heart failure, from the same image. So that should be a little concerning to you, that we as humans are open to defaulting to what a machine interpretation of a chest X-ray says, even if it like is biased, even if it's making mistakes interpreting pneumonia when there's like literally no pneumonia in this top part of the image. So I just think that's an interesting and important thing for as we start to think about how AI works and the challenges of it. It's really important that clinicians are involved in this. Now you can see here that this took like 41 seconds to process. Oops, I'm processing it a second time here. And this is not like ChatGPT. This is not like you're getting an instant response from the large language model, because it has to process an image that takes a lot more time. Now you could reduce that time if you had more RAM and a more powerful graphics processing unit, GPU, a more souped up computer. But also consider that like nobody gets an immediate chest X-ray read, and so to me, that's probably okay. That's not a problem that I have with a model. Usually in the ER, if I'm getting a chest X-ray, the patient's not even physically back from radiology within 41 seconds or 2 minutes from the radiology tech hitting the button to get the chest X-ray. So don't necessarily think of this as a problem that you're not getting an instantaneous response like you might be with a chat model like ChatGPT or Gemini or something like that. The other thing that I think is interesting to point out is, how is a large language model actually interpreting images? So think of this model as like calling on a buddy, a friend that's a really good chest X-ray interpreter. So the large language model takes your prompt and then it like kind of consults, a radiology model and says, "Hey, this Dr. Walker wants a chest X-ray read. Can you help me out?" Sends it over to the chest X-ray model, and then the chest X-ray model sends back information that then the large language model turns back into English text for me. So again, this is using a large language model, but it's multimodal. It can do imaging, but obviously there's not images, there's not text in this chest X-ray that the thing is reading. I just wanted to call that out. The last thing I will say is, if this seems intimidating to you, it's okay. The really amazing thing about this stuff is you can use AI to make this stuff more explainable. You as a doctor, as a clinician, you are probably really good at learning things really quickly. That's one of our skill sets. So imagine you can take this URL and you're like, oh, what is a SIGLIP image encoder? So let's just go over here and say, explain. This is a Google Gemini. Explain a SIGLIP image encoder like I'm a 5-year-old, and then I'll give it the URL here, so it knows kind of the context. You don't have to do this. I just like to. And okay, it's explaining what. Look, it has a super smart friend called a cyclic image encoder. It's like a buddy that can read the chest X-ray. So that's the other cool thing is if there are terms or technology or acronyms in this information that seems not intuitive or obvious to you, you can use AI to help understand it better and get a better understanding as well. So I will wrap up there. Thank you for watching. Sign up for our free webinar. We're going to talk about even a more basic level of like what is AI, what are the different types of AI, and we'll use clinical examples that matter to you as a clinician. So thank you so much for watching. This has been and continues to be Dr. Graham Walker. Have a great day.